Prepare to have your understanding of the early universe shaken. A hidden population of gigantic black holes, cloaked in dust, has just been revealed, contrary to everything astronomers thought they knew. Could this be the missing piece in the puzzle of how our universe grew and evolved? But here's where it gets controversial. These concealed monsters might actually be twice as common as anyone suspected. A global coalition of astronomers, including teams from Ehime University and Japan's NAOJ, has made a breakthrough discovery. Initially, they used the Subaru telescope to identify galaxies that seemed promising, and then brought in the mighty James Webb Space Telescope, JWST, to investigate further. What they found was nothing short of astonishing. These galaxies host supermassive black holes behaving as blazing quasars, surrounded yet hidden by cosmic dust. The findings, now published in the Astrophysical Journal, transform our understanding of just how many of these bright, powerful quasars populated the universe less than 1 billion years after the Big Bang. Let's zoom out for a second. Today, nearly every galaxy, including our own Milky Way, harbors a supermassive black hole at its core, some weighing millions or even billions of times more than our Sun. Most of the time, these cosmic heavyweights lie dormant, but occasionally, they feast on nearby matter, turning into extremely energetic objects known as quasars. A quasar's energy output is so fierce it can reshape its home galaxy, driving out gas and influencing galaxy growth. So tracing their origin is key to understanding cosmic history. That brings us to a long-standing mystery. How did these colossal black holes appear so early? Only 1 billion years after the Big Bang. Did they arise from the deaths of the universe's first stars? Scientists have hunted for quasars at the so-called cosmic dawn, hoping their numbers would shed light on this process. A high count hints at an everyday origin, while fewer quasars would mean only select conditions could birth these giants. Conventionally, researchers identified quasars by their ultraviolet emissions, which, interestingly, reach us as visible light. These emissions also reveal themselves through broad spectral lines, a consequence of gas swirling at high speeds near the black hole. But here's the part most people miss. Ultraviolet light is easily swallowed up by dust, and many galaxies are rich in this cosmic powder. That means countless quasars could be hiding right under astronomers' noses, their signals muffled so much they've eluded every previous survey. Determined to dig deeper, the research team pointed Subaru's powerful Hyper-Suprime cam at the brightest galaxies found in wide sweeps of the sky. These galaxies stood out in earlier searches but lacked the spectral fingerprint, broad emission lines, of known quasars. Yet the scientists weren't convinced, suspecting for a decade that something energetic was lurking inside these dusty galaxies. The arrival of JWST changed everything. With its ability to spot infrared light, JWST could peer through the dust, revealing what optical telescopes could not. Between July 2023 and October 2024, a team used JWST's near-spec spectrograph on 11 brilliant galaxies. Here's where it gets exciting. 7 of these galaxies displayed unmistakable broad emission lines, the sign that supermassive black holes are actively gobbling up matter and shining as quasars. These are the first confirmed examples of bright, dust-shrouded quasars from the universe's infancy, a game-changing discovery. Some might argue this isn't entirely new, pointing to earlier reports of dim, dusty quasar candidates dubbed little red dots, but none of those showed the crucial broad emission lines. Unlike their faint predecessors, this latest batch matches the luminosity of classic, unobscured quasars. Only their brightness is dimmed by thick veils of dust. Taking a closer look, the team found these newly revealed quasars blaze with the energy of trillions of suns, powered by black holes with masses comparable to those previously spotted in the early universe. What's more, dust absorbs around 70% of their visible light, and almost all, 99.9% of ultraviolet output. No wonder they escaped earlier searches, relying solely on ultraviolet signals. Ready for another bold claim? By comparing the frequency of obscured and visible quasars, astronomers now believe bright quasars in the early universe are at least twice as numerous as previously estimated, a finding that's certain to spark debate. Does this mean our models for black hole formation and galaxy evolution need a major overhaul? Dr. Yoshiki Matsuoka, who led the study, credits the novel combination of Subaru's sweeping surveys and JWST's infrared capabilities as the key to this breakthrough, calling the strategy Discover with Subaru, Explore with James Webb. So, what comes next? The team is embarking on follow-up studies to see if these concealed quasars differ in any fundamental way from conventional ones. By combing through JWST's detailed spectra and complementing it with data from the ALMA telescope, they hope to reveal the complex environments around these black holes. Beyond that, they're preparing a wider hunt for hidden black holes in more ordinary, dimmer galaxies, hoping to uncover just how many supermassive black holes lived in the universe's earliest days. With a new JWST program on the horizon, big discoveries are expected soon. But what do you think? If twice as many massive black holes were lighting up the early universe, does this challenge everything we thought we knew about cosmic evolution? Or could these findings fit into current models with a few tweaks? Is dust the villain, keeping secrets from astronomers? Or might there be even more surprises yet to uncover? Let us know where you stand. Are you convinced, stunned, or skeptical? Share your thoughts below and join the cosmic debate.